Hello everyone, my name is Kanak Manjuri. I'm a PhD research scholar in Computer Science Department in Bennett University. So in this video of mine, I'm going to discuss about the topic art generation. So art generation is basically the area of style transfer. So in this, I'm going to transfer the style uh, in images. So these are the contents which I'm going to discuss in this video: the introduction, the example, what's perceptual loss function, what content losses, what style losses, its working, and about convolution network. Okay? So first of all, what is art generation? So basically, it's a process of recomposing style of one image onto the content of another image. Suppose if we have two images, one image has an object, like object in terms of there will be an image of any object, be it chair, be it human, be it any object, and another image contains style, suppose some modern painting or some other style. And if I want to impose the style of that style image onto the content of the content image, so for this purpose I have used style transferring here. So in all these slides of mine, I'm going to use this convention. For content image, I'm going to use C. For style image, I'm going to use S. And for style transferred image, that is generated image, I'll use capital X. So basically what it does is, it transfers the low-level features like color, texture, etc. from style image to the high-level features such as content, uh, semantics, etc. to the content image. And after combining the both, it generates a new image, that is style transferred image. Okay. So basically, in this is the example. The first image is a content image. It contains a content, that is any object. It is mountain. The second image is you can say a modern painting which contains its particular style. So the last image is the combination of both image. It has the content of the first image, that is mountain, and it has the style of the second image, right? So this is what I'll be discussing here. This is the another example. This first image is the content image, that is there is a content that is any object, that is a baby is there, and the second image is a style image. There is no content here, that is there is no object, there is this style. So I want to impose the style of style image onto the content of the content image. So this is the generated image where the style is transposed upon the content. Okay. So first of all, we need to discuss about what this perceptual loss function is and what per pixel loss function is. Okay. So the content and style loss are based upon the perceptual loss function, not on per pixel loss function, right? So like if you want to compare two images based on high level representation from pre-trained network, that is perceptual loss function. And if you want to compare two image on the basis of pixel difference, that is per pixel loss function. So here we do not compare per pixel loss function, we compare perceptual loss function, that is high level features and low level features. Okay. Now what is content loss? Content loss is the comparison between the loss of content, right, from the content image and from the generated image. That is, the first image is content image and the second image is generated image. So the loss of content from the content image to the generated image. So our aim is to minimize this content loss. That is, the object should be properly visible in the generated image. Now next is style loss. Style loss is the loss of style between the style image and the generated image. So our aim is to minimize the style loss also from the style image to the generated image. Now how it works? So we are looking for an image that differs somewhat with content image and which contains the style of the style image. So alpha and beta in this mathematical equation are some hyperparameters. Through this alpha and beta, we can control how much amount of style we want to impose upon the content image. So this alpha and beta are the hyperparameters which gives us the flexibility. This now with alpha there is the content loss between the content image and generated image, and with beta there is the style loss between style image and generated image. this is the another example. And we have a style image, right? We have a content image. Style image, we extract the low level features, and we minimize the style loss. And through content image, we extract features and we minimize the content loss. And on combining both, we get a new generated image which contains the content of the content image imposed style. Also, if you want to invert the content image, this is also possible here by mask transfer. For this purpose, I have used TensorFlow, few libraries of machine learning like PIL. PIL is a pillar library used for image manipulation. SciPy is used for optimization. Also, we have used convolutional neural network. Convolutional neural network are basically pre-trained for image classification and are pre-trained with ImageNet database. Here in this program, I have used VGG16 database, VGG16 model for this training purpose. So first of all, I'll show you the code and then I'll show you how it is working. Okay, so let's see. See, these are all the libraries which I have used. This time library through which we calculate the time. This is the PIL library, this is the pillar library, which is used for manipulation of images. NumPy you already know for the arrays and arrays, 3D arrays calculations. Keras I guess you already know, right? So for this I have used VGG16, right? SciPy is used for optimization. For loss, we want to optimize. So I have used this fmin-l BFGS algorithm, okay? And this IamSafe I am using for saving the image. So first of all, what I need to do is, I want to load the content image and I want to load the style image. So first of all, I have defined the height and width, okay? Now I am uploading the content image. This is the content image which I have uploaded. Now here I have uploaded the style image. This is the style image I have uploaded. Now I want to convert the content image to some numerical data. So I have changed it. It is a 3D. Now for the calculation thing, I want to concatenate one more dimension. Okay, so I have added this np.expand dimension. Now I want to convert style image also, as we have converted content image to numerical data. So I want to convert style image also to the numerical data, and then I want to add one more dimension. So this has been done here. Okay, converted into numerical data, and then one more dimension has been added. Now what we have done here is we have subtracted the RGB mean and we have done RGB reverse ordering. This is the mean of red, this is the mean of green, this is the mean of blue, and we have done the reverse ordering. Okay, now we are making these values ready for VGG16. Okay, so the content array which contains the content image and the style array which contains the style image. So in the content array contains the array of content image, this contains the array of style image, not the multiple content image, but the this for the dimensions, what we have taken the mean of RGB, that thing, and we have passed it into the content image variable, style image, and combined image through the backend dot variable. So we are concatenating all this. This is the predefined format. So content image, style image, and the combination image. Now we are running it. Now the model we have used here is VGG16. Here the input tensor equals to input tensor, which has all the parameters. Weights equals to ImageNet, that is we are using ImageNet database. Okay, this is the summary. This is all the layers which are there in VGG16. It has 16 layers, and which layer is there, which activation function we are using. This is the information of VGG16. Okay, now we want to define, as I have told you, alpha and beta are the hyperparameters which gives us the flexibility of how much amount of style we want to impose upon the content image. So basically it is not the how much amount, this is actually the loss, right? So maximum what we can afford is content weight loss is 0.025, the style weight loss is 5.0, and the total variation width should be 1.0. This is the maximum loss we can afford. We can change it as per our requirement, right? Now this is the content loss. This is a function which we have made to calculate distance between the feature representation of the content and the combination image, right? And this similar we need to do is for style loss, but for that style loss we gonna we are gonna make a gram matrix. Gram matrix is a matrix which becomes unchanged even if it is transposed. So this is the function of making gram matrix, and then this style loss function is made. Okay, now we need to calculate the total variation loss. This is a regularization term. This is used to regularize. Okay, so this is a function of this. Now gradient is there defined here. Now we need to evaluate using the loss we have computed, the gradient, etc. So this is the evaluate loss and gradient function. This is the evaluator class, and this is the evaluator. Now we are using ELF, as I have already told you, LVFGS algorithm. This is a quasi-Newton algorithm that's significantly quicker to converge the standard gradient descent. Okay, so now here we have used iterations 10. As we can, if we increase the number of iterations, the generated image will become more beautiful, will become more perfect, and the loss will keep on decreasing. As we increase the number of iterations, the loss will decrease. But here for only demonstration purpose I have used only 10 iterations. This is the loop. Okay, so here I am printing the time, and I'll show you the start of iteration, that is which number of iteration it is running, start time. Okay, now this is the F-min LBFG's algorithm. This is algorithm which calculates all this thing, then we are calculating current loss value, then we are calculating the loss iteration, how much time one iteration is taking to complete, that is start time minus end time minus start time. So you can see this start time, start of iteration, this is the iteration number 0, current loss value, this is the loss value, and now iteration 0 completed in, it is end time minus start time. So this has happened for all the 10 iterations. Now after 10 iteration from 0 to 9, we can again reverse back the input image, okay, from BGR to RGB, as we have done in the previous, like first of all we added in one more dimension, and then we have converted into RGB into BGR. So for that we are reverse backing it to RGB, and then we are displaying the result we have got. So as you can see here, this was the input image, content image, this was the style image. So the generated image is this is quite beautiful. Okay, this has the style of our style image and the content of our content image. Okay, the same thing I have implemented on this link. This is the art-generator.connectmentary.com. what you can do is, here you can upload any image, okay, content image which should have a content, and then there are 4 styles here, out of which you can select any style. Suppose I have selected this style and I can submit. After submitting, this happens. You can see here the above, this is waiting for signals, like we have done it for 10 iterations. As each iteration will be completed, it will show here, suppose one iteration is complete, it will show 1 out of 10 iterations have just completed. So let's wait for one iteration. Actually it takes around 1 minute of time for one iteration, because I have hosted it upon normal server, not any NVIDIA server, so DGX server, so that's why it will take 10 minutes of time. So it will generate almost similar kind of image, like the content image and style image will generate a content plus style image which contains the style of something. Similarly it will generate the content, right, the content plus style of the image. As you can see here, if we want to use this image of house, and if I want to use the style, so after submitting, it will complete the iteration. You can see here you can see for this for the previous content image, one iteration has been completed. So after all the 10 iterations are completed, the generated image will be shown here. Similarly for this also, for the house image which I have shown you in this, after the 10 iterations will be completed, the generated image, the style transferred image will be shown here. It is almost similar to this. So you can try it by your own, right? You can get the code on my GitHub profile, that is in my GitHub ID is kmanjuri, right? And you can run this project by your own. I'll provide the URL in the description box, right? You can run it by your own and you can check it, how different content image combining with different style image, what style transferred image you are getting, right? So I guess the basic of this topic is clear, right? And there are many future work and drawbacks also, like as you can see here, the original color of content image is this, but after this style is transferred, along with the style, the color of styles image is also transferred to the content image. So what we only want, what if we only want to transfer the style of the style image, not the color? We want the color of content image as it was, so we need to do color preservation. So many different constraints are there on which work are being done, research are being done. So you can rate it, we can try it also. You can try so here, as we have used only one style image for transferring this style, you can use multiple style image and you can control it by the hyperparameter, how much style loss you want for particular style image and how much style loss you want for another style image. So you can use this program and you can modify it and you can run it according to your needs. So I guess this video is useful for you. Thank you so much.